Hi students, now I am going to teach estimation of hardness by EDTA method. Let me see what are the contents we are going to discuss in this topic. We are going to discuss the first one is aim, and the second one is chemicals required, third one is principle and reactions, in the principle we are going to discuss about structure of EDTA structure, followed by short procedure or method to carry out the estimation of EDTA, and the last one is calculations. In the calculation part, we are having three subdivisions. The first one is standardization of hard water. The first one is standardization of hard water, and the second one is estimation of hard water. In this estimation of hard water, we will find out the total hardness. We will find out the total hardness. And the third one is estimation of boiled hot water. Estimation of boiled hot water. Here what will happen? See, here first we are standardizing the normal standard hot water. Actually, it is a standard hot water. We are standardizing the standard hot water. And in the second part, we are estimating the hard water. The hard water contains both temporary and permanent hardness. Actually, hardness is two types, temporary and permanent. So, this one, the hard water contains both temporary and permanent hardness. So, while we are estimating the hard water, we can get the result for the total hardness. And what will happen in the next step? See, here the same hot water is subjected to boiling. While boiling, what will happen? As I told earlier, the hot water contains two types of hardness, temporary hardness and permanent hardness. Permanent hardness cannot be removed by the simple boiling, but we can remove the temporary hardness by the simple boiling. So, while boiling the hard water, the temporary hardness can be removed. So, the boiled water contains only the permanent hardness. So, here we can get the result of permanent hardness. See, here we have determined the total hardness, then we have determined the permanent hardness. By comparing the total and permanent, so we can get the temporary hardness. We can get the temporary hardness. So these things are we are going to discuss elaborately. So first aim, why we are going to do this experiment, and what are the chemicals required for doing this experiment. Third one is principles. In the principle, we are going to discuss the reactions and reasons for the color change and structure of the EDTA. Fourth one, procedure. So what is the procedure for? Actually, we are having three titrations. The first one is a standardization. Second one, estimation of sample water, and third one is the estimation of boiled water. So for these three titrations, how the titrations are done, that short procedure we are going to discuss in the next step. Finally, calculations. Once the titration is done, by the Burette value, we need to calculate. So the calculation we are going to discuss in the last step. So before that, before discussing all the things, we should know some basic concepts about the terms what are involved here. See, what are the terms involved, basic terms involved here? Let me see. Estimation of hardness. So the first term involved here is hardness. And one next term, see, I have mentioned it, yes, EDTA. Later we will discuss elaborately about the structure. So before that, we should discuss about what is meant by EDTA. And in this experiment, we are going to estimate hard water. So what is mean by hard water? What is mean by hard water? So what is the vice versa for hard water? That we will also discuss. It is a soft water. The vice versa of hard water is a soft water. And see, if the soft water contains some hardness causing constituent, it becomes a hard water. We will also see what are the hardness causing materials. What are the hardness causing materials? So these things we are going to discuss before starting the explanation. Okay, let me see. The first one is hardness. Hardness is the property of water which does not lather with soap solution. See, let us imagine if you go for a beach and you are taking a bath. So after that, if you are using a soap or you are using a soap to wash your hand by the seawater, what will happen? What will happen? So when you wash the hand by using a soap in a seawater, it may stick in your hand. So the reason is the seawater contains a lot of salts, lot of calcium, magnesium, and sodium salts. So the soap will react with the sodium, calcium, and magnesium salts. Actually, it will not react with the sodium. It will react with the calcium and magnesium salts, and it will form white scummy precipitate. So the precipitate is the reason for not lathering. So the same thing will happen here. So hardness is a property of hard water which does not produce a lather with a soap solution. The next one is, last we will discuss about EDTA. The next one is a hard water. So hardness is a property of hard water. And what is meant by hard water? The water which does not produce lather with soap solution. Why? What will happen? As I told earlier, in case if the water contains calcium and magnesium salts, so it may cause disturbance while lathering. So it forms a white scummy precipitate. So that will not allow soap to react with soap to lather. That is one is a hard water. And next one is a soft water. The water which produce a lather with soap solution. If does not produce a lather with soap solution, that is called hard water. If produces lather with soap solution, that is called soft water. Let me see why the hard water does not produce a lather with soap solution. It contains a hardness causing constituents. What are the hardness causing constituents? The hardness causing constituents are calcium, magnesium. Calcium, magnesium. So, if the calcium and magnesium present in the water, it will does not produce a lather with soap solution. And if calcium and magnesium salts present in the water, what will happen? It results the hardness. If calcium and magnesium salt, which is hardness causing constituents, hardness causing materials present in the water, means it results the hardness. The hardness is two types. Hardness is two types. Temporary hardness and permanent hardness. The hardness is two types, temporary hardness and permanent hardness. The name itself containing the meaning. What is temporary hardness and what is permanent hardness? The temporary hardness can be removed by the simple boiling. For example, you may observe at your home, if you boil the tap water, not reverse osmosis treated water, just a tap water for a bathing purpose or any other purpose, if you just boil the tap water in the gas stove, after some time, so after boiling the water, you may notice some white color precipitate may float on the water. The white color precipitate may float on the water. The reason for floating the white color precipitate on the surface of water is salts. Which salts? That is a temporary hardness causing salts. What are the constituents responsible for temporary hardness? So, before that we will discuss what is meant by the permanent hardness. Permanent hardness cannot be removed by the simple boiling. The temporary hardness can be removed by the simple boiling, but permanent hardness cannot be removed by the simple boiling. So, it needs some other process to remove. What are the process we may? For example, we can say a demineralization process, zeolite process. So, these processes are necessary to remove the permanent hardness, but the temporary hardness can be removed by the simple boiling. Let me see what are the constituents responsible for temporary and permanent hardness. The salts responsible for temporary hardness are bicarbonates of calcium, bicarbonates of calcium, then bicarbonates of magnesium, bicarbonates of magnesium. So, these two salts are responsible for the temporary hardness of water. And then next, what are the constituents or what are the chemicals responsible for the permanent hardness? Chlorides of calcium, chlorides of calcium, then chlorides of magnesium, chlorides of magnesium, and then sulfates of calcium, and then sulfates of magnesium. So these are the 4 salts are responsible for the permanent hardness, which means what it shows, it is the chlorides of calcium, mean it is a calcium chloride. It's nothing but a calcium chloride. And what is meant by chlorides of magnesium? It is a magnesium chloride. It is magnesium chloride. And sulfates of calcium, calcium sulfate, CaSO4, and sulfates of magnesium, magnesium sulfate, magnesium sulfate. Here, so these are the molecular formula of salts which cause the permanent hardness. And what are the molecular formula of salts which cause the temporary hardness? Bicarbonates of calcium means calcium bicarbonate. And what is the structure? What is the molecular formula of a calcium bicarbonate? Calcium, calcium having a bivalency, bicarbonate having a monovalency. So, bivalency calcium is joined with two molecules of bicarbonate, calcium bicarbonate. Same, magnesium bicarbonate, magnesium also having a bivalency. So, it belongs, the calcium, it belongs to the alkali earth metals. So, bivalency, here MgHCO3 twice. So, these are the structure of, these are the molecular formula of calcium and magnesium bicarbonate, which cause the temporary hardness of water. So, these are the introduction thing, key thing. So, you must know before discussing the estimation of hardness by EDTA method. So, once again I will recall and then we will enter into our topic. Hardness, it is a property of hot water which does not produce lather with soap solution. Hot water, the water which does not produce a lather with soap solution is called hard water. The reason is the hard water contains a calcium and magnesium salts. The vice versa is a soft water. If the water lather with soap solution, that is called a soft water. And if the soft water is converted into hot water, means it contains a hardness causing materials. What are the hardness causing materials? Majorly two cations, calcium and magnesium. See, the hardness itself classified into two types, temporary hardness and permanent hardness. See, there are two types of hardness, temporary and permanent hardness. If the hardness is temporary, or we can remove the hardness by the simple boiling, we can call it as a temporary hardness. If the hardness cannot be removed by the simple boiling, so that is called a permanent hardness. So, these constituents, calcium bicarbonate, magnesium bicarbonate, are responsible for temporary hardness. In the case of permanent hardness, the hardness causing constituents are calcium chloride, magnesium chloride, calcium sulfate and magnesium sulfate. And then here I have written one abbreviated term, EDTA. So, in this experiment, we are going to determine the hardness by this method. Which method? EDTA method. The EDTA stands for ethylene, diamine, tetra acetic acid. It stands for ethylene, diamine, tetra acetic acid. So, these are the information we are going to see in this experiment. Let us enter into the discussion. Okay, the first one is aim. It's as simple as a single line. We are going to estimate the hardness of water by EDTA method. So, as I mentioned earlier, there are two types of hardness, temporary hardness and permanent hardness. If we club the temporary hardness and permanent hardness, that is called a total hardness. So, in this experiment, the aim is we are going to determine temporary, permanent, and total hardness. We are going to determine temporary, permanent, and total hardness. And this is the aim. Let me see what are the chemicals required to do this titration. What are the chemicals required for this titration? See, the first chemical required for this titration is EDTA, ethylene diamine tetraacetic acid. EDTA stands for ethylene diamine tetraacetic acid. And then we need standard hard water. Standard hard water. Standard hard water. Then, so standard hard water is used for the standardization purpose. In a standardization, we will use a standard hard water as a pipette solution. And then sample hard water. Sample hard water. A sample hard water is used in the estimation of hardness or estimation of a total hardness. In a second iteration, we will use the sample hard water. And the next one is a boiled hot water. Boiled hot water. Boiled hot water. In a third iteration, the pipette solution is a boiled hot water. As I mentioned earlier, if the sample water is subjected to boiling, the temporary hardness will be removed. So, by using a boiling hot water, we can determine the permanent hardness. And what are the other things required? The indicator used for this titration is EBT. EBT stands for eryochrome black tea. EBT. EBT, which is eryochrome black tea. Eryochrome black tea is indicator which is used for the complexometric titration. Actually, titrations are many types. Acid-based titration is there. For example, in 11th and 12th standard, you may study the titration between the sodium hydroxide versus hydrochloric acid. Even it may differs, strong acid versus weak base versus strong acid. For the titration, you may use phenolphthalein as indicator, methyl orange as indicator. But here, it is a complexometric titration. Complexometric titration means during the course of reaction, it will form a complex. So it is going to form a complex. That is why it is called a complexometric titration. So the indicator used here is EBT. In addition to that, we will use ammonia buffer. Ammonia buffer. Now the question may arise, what is mean by buffer? What is the role of buffer in the titration? So buffer is used to maintain the pH. So if you use ammonia buffer, actually the two types of buffer will be utilized, acid buffer and base buffer. In this titration, we are using a base buffer, that is the ammonia buffer. While using a base buffer, the reaction condition is maintained in the pH range from 8 to 10 or 8 to 9. So it maintains the pH in the base medium. So that is the role of a base buffer. Ammonia buffer is example for base buffer. It is an example for base buffer. So these are the chemicals required for the titration. So let me see the principles, reactions, and the structure of EDTA. The next one is principle. Third one is principle. In the principle, we are going to discuss reactions happening during the titrations and the structure of EDTA. First, we will discuss the structure of EDTA. Structure of EDTA. First, we will discuss the structure of EDTA. See, it contains a combination of 2 to 3 chemicals. Ethylene diamine tetraacetic acid. So let me discuss one by one. So how we can write the structure of EDTA. What is the structure? Molecular formula of ethylene, it is a C2H4. How can you write the structure of ethylene? C, double bond C, H, H. So it contains 4 hydrogens. So this is the structure of ethylene. So I have written the ethylene. Now diamine. So ethylene is written diamine. So the double bond is converted and wait a minute. C See, here the hydrogens present in the ethylene molecule is replaced by the amines. So finally, the acetic acid group will be replaced. So what will happen? What will happen? One, two, three. So this is the structure of EDTA. So ethylene diamine tetraacetic acid. Let me see the reactions involved in these titrations. So what are the reactions involved in this titration? So let me see. Before discussing the reactions involved here, let me imagine what are the things we are going to do. So we are going to do the 3 titrations. So this is a burette. And this will be the conical flask. Okay, this will be a conical flask. Let me see. In a burette, we are going to take EDTA. In a burette, we are going to take EDTA. In a conical flask, we are going to take a hard water. In a conical flask, we are going to take a hard water. Here, in a hard water, the additional solution used here is buffer. So buffer is going to add in a conical flask. Also, the indicator will be added in the conical flask. Indicator is EBT. So this is the systematic procedure. Let me see. So what will happen? What are the things first we are going to take? So we are going to take a conical flask. In a conical flask, we are going to pipette out the hard water. It may be the standard hard water, it may be the sample hard water, it may be the boiled hard water. So the hard water contains, as I told earlier, it contains Ca2 plus or Mg2 plus ions. It contains Ca2 plus or Mg2 plus ion. So we are pipetted out the hot water which contains the salt. Now we are going to add buffer. The role of the buffer is it maintains the pH in a base medium. So it will not involve in a reaction, but it maintains the pH in a base medium. And then we are adding a indicator. It is a complex-somatic titration. We are adding EBT indicator. EBT stands for eriochrome black tea. Here we are adding a buffer. The buffer is used to maintain the pH from 8 to 10 or 8 to 9. Now, it will form unstable complex. It may form calcium 2 plus or magnesium 2 plus complex with EBT. Calcium 2 plus or magnesium 2 plus complex with EBT. So, we are taking conical flask, added the hot water, and just we are added the indicator. So after adding the indicator, so it looks wine red color. It looks wine red color. The original color of EBT is a steel blue, but when the EBT is added with the hot water, the hot water contains the calcium and magnesium salts, so it combines and it forms weak complex. So this is the first step of the reaction. So now the weak complex is formed. Now what we are going to do, this solution, this mixture is going to titrate against the EDTA taken in the burette. So in a burette, we are taking the ethylene diamine tetraacetic acid, which is simply abbreviated as EDTA. This has been taken in the burette. So EDTA is titrated against the complex formed here. What are the complex formed here? Calcium 2 plus or magnesium 2 plus EBT complex. So what is formed there is calcium 2 plus or magnesium 2 plus EBT complex. Now what will happen? During the titration, what will happen? You know, the bond between the calcium and EBT or magnesium and EBT is a weak, it is unstable complex. When you are titrating against a EDTA, the bond between the calcium and EBT, the bond between the magnesium and EBT will break and it will form, the calcium and magnesium ions will form strong bond between the EDTA. So the resultant compound is Ca2 plus or Mg2 plus form strong complex, stable complex. So this is the resultant product, and the color of the resultant product is what? What initially I told, the wine red to steel blue, but the color of the resultant complex is not steel blue, it is a colorless. Now the question arises, sir, you told the endpoint is wine red to steel blue. Initially, while adding the EBT with the calcium and magnesium, it turns wine red color. Initially, you told during the titration you will get a steel blue color, but you are writing calcium EDTA as a colorless complex. Why, sir? What is the reason? See, we are added the EBT. EBT forms a weak complex with calcium and magnesium. When it titrate against the EDTA, it forms strong complex. But the EBT, that is the indicator, comes out. The additional product formed in this reaction is EBT. As I told you earlier, I hope you remember, the color of the EBT is a steel blue. So the reason for the formation of a steel blue color is, which indicates, so the calcium and magnesium, all the calcium and magnesium present in the conical flask is completely reacted with the EDTA. So that is the reason for the colorless complex of calcium EDTA or magnesium EDTA, and the color of EBT is a steel blue. Color of EBT is a steel blue. That is why the endpoint of this complexometric titration is wine red to steel blue. Wine red to it is a wine red to steel blue. So wine red color is the reason for the formation of a calcium and EBT complex, and the steel blue is responsible for the formation of, actually the formed complex is a colorless, but the EBT, the indicator colors, retains. So this is the endpoint. Next we will move to the procedure. Short procedure. Fourth one is short procedure. We are having a 3 set of titration. First, we will start with the what is the short procedure for standardization of hard water. The first part is standardization of hard water. Standardization of hard water. First iteration is a standardization of hard water. Okay. Here, the few things we need to remember. What are the solution? What is the solution used for a burette purpose, and what is the solution used in a pipette, and what are the additional solution is used, and indicator. So, things we need to learn are what is burette solution. What is pipette solution? What is the additional solution? Burette solution, pipette solution, additional solution, indicator. Indicator, the last one is a endpoint. See, already I have drawn one diagram. So, this is the burette. Let us imagine this is a conical flask. I may pour in a drawing conical flask. See, so this is a titration method. Here we are going to take what? Here we are going to take what? That we are going to discuss here. For a standardization, we are going to take standard EDTA as a burette solution. Standard EDTA as a burette solution, that will be taken here. So, the first one will be taken in the burette, and the second one, pipette solution. Sorry, I have done one mistake. It is a EDTA. Actually, we are going to standardize here. So, in the next iteration, we will call it as a standard EDTA. Here it is a EDTA, it is not standardized. Now, we are going to standardize. So, it is a EDTA. Pipette solution is a standard hard water. Pipette solution is a standard hard water. An additional solution is base buffer. Additional solution is ammonia buffer. So, as I told earlier, the buffer is used to maintain the pH in a base medium. Indicator, aerochrome black tea. Aerochrome black tea will be used as a indicator, and the endpoint is wine red to steel blue. So these are the short. This is the short procedure. This is the short procedure. Let me see. The burette solution is a EDTA that will be taken here. That is taken in the burette, and the hard water will be pipetted out here, and additional solution, the buffer will be added here. The indicator will be also added here. So after adding these three things, it becomes wine red. It becomes wine red. So after this complex formation, this complex is titrated against the EDTA taken in the burette, and this is the procedure and this is a method for a standardization of hard water. Next, we will discuss the estimation of total hardness, and this is a standardization of hard water once the hard water is standardized. Hard water is standardized, then sorry standardization of its EDTA, because we are taking a hard water to standardize the EDTA. I have written it as wrong. Standardization of EDTA. So we are going to use a EDTA for a standardization purpose. So before using a titration purpose, we need to standardize the EDTA. So here now the EDTA is a standardized. That is why here I have mentioned it is a not a standard EDTA, it is a EDTA. Okay, so we are going to standardize the EDTA. Now the EDTA is standardized by using a standard hard water. So EDTA is standardized by using a standard hard water. There are three titration. This is the first titration. This is the first titration, which is standardization of EDTA. The second titration is estimation of total hardness. The second titration is estimation of total hardness. Estimation of total hardness. The same procedure what we have discussed for the standardization of EDTA will be followed here. The only one change, the burette solution is the same, but the change is instead of standard water, instead of standard hot water, we are going to take a sample hot water. Instead of standard hot water, we are going to take a sample hot water. The same thing, other the contents are the same. What are the contents? What are the requirements? What are the things we need to know? Burette solution, and the second one is what? Pipette solution, additional solution, indicator, endpoint. Endpoint. Let me see what are the things used here. So these are the common terms we need to remember for all the titration. In our first titration, already we have standardized the EDTA. So before we have simply called it as a EDTA. Now it is called as a standard EDTA, because we have standardized the EDTA. Now it is called a standard EDTA. and the pipette solution is a sample hot water. It is a sample hot water. The remaining things are same. Additional solution is a base buffer, indicator the same, Eriochrome black tea. It is abbreviated as EBT. The endpoint wine red to steel blue. The endpoint is wine red to steel blue. So the other things are same. So only one change is done. Instead of a sample water, instead of a standard hot water, we are taken the sample hot water. So this will be taken in the burette. First, we are going to pipette out the sample hot water. In general, we will pipette out a 20 ml of sample hot water, usually in a laboratory. This quantity will be used, and around 5 to 6 ml of base buffer will be added with the sample hot water, and we are adding a 2 to 3 drops of Eriochrome black tea indicator. So while adding these three contents, it forms a weak complex, that is calcium or magnesium complex with EBT, and that color is a wine red. So after the formation of a calcium magnesium EBT complex, it shows a wine red color when it is titrated against the EDTA. Already we are standardized, so when it is titrated against the standard EDTA, it becomes a steel blue. So from the answer, from the volume, now we can know the what is a total hardness. What is a total hardness? In a calculation part, we will discuss elaborately. And the third one is estimation of permanent hardness. Third one is estimation of a permanent hardness. The contents are the same. What are the contents used? Burette solution, the second one is a pipette solution, additional solution, indicator, and the last one is a endpoint. So these things are we need to keep in mind, because while writing the short procedure of all the three titration, so these contents are common. So these things we need to remember in mind. Here we are going to estimate the permanent hardness. So permanent hardness means what will happen? So the temporary hardness is removed. How to remove the temporary hardness? So by the simple boiling. That is why the first iteration we have standardized the EDTA. So that will be done by the standard hot water. A second titration, sample hot water is estimated. In a third titration, the water which is used in a second titration will be boiled. During the time of boiling, during the course of boiling, the temporary hardness will be removed. Now the water will be free from the temporary hardness, and it only contains the permanent hardness. So the burette solution is standard EDTA, and the pipette solution is boiled hard water. Boiled hot water. Additional solution is the same, that is the indicator. Sorry, additional solution is a buffer. So ammonia buffer is used. Actually, ammonia is a gas. When the ammonia is mixed with the water, if it dissolved with the water, it will become ammonium hydroxide. The indicator is aerochrome black tea, which will be abbreviated as EBT, and the endpoint is wine red to steel blue. Endpoint is wine red to steel blue. So, like first and second titration, the procedure is the same, only the concept is vary. The EDTA solution will be taken in the burette. There is no change in a burette solution. First, you are going to pipette out boiled hot water in a clean conical flask, and then 5 to 6 ml of ammonia buffer will be added with the boiled hot water, and 2 to 3 drops of indicator. After adding the indicator, it forms a weak complex, calcium or magnesium weak complex with EBT will be formed in the conical flask, which results wine red color. So after that, this complex, this weak complex is titrated against the EDTA. While titrating EDTA, the bond between the calcium, magnesium and EBT will break because it is a weak, because it is unstable. It breaks and it forms a strong complex with the calcium, magnesium, forms strong complex between the calcium, magnesium with EDTA. So that is the results for the steel blue. During the end of the course of reaction, the EBT indicator comes out. The original color of EBT is steel blue. So the results, the reason for steel blue is the indicator is not involved in the reaction, it comes out. So this is the estimation of permanent hardness. Now we will see the calculation part. The last one is the calculation part. Last one is the calculation part. So we are having 4 parts here. The first one is a standardization. Second one is determining the total hardness. Third one is determining the permanent hardness. Last one is determining the second one is determining total. Third one determining the permanent. The last one is determining the temporary hardness. So the first one, standardization. The first part is a standardization. Here you should know what is mean the standard hard water. 1 ml of standard hard water contains 1 milligram of calcium carbonate. So it contains 1 ml. So usually we all take 20 ml of standard hard water. If 20 ml of standard hot water contains 20 mg of calcium carbonate equivalent. It contains a 20 mg of calcium carbonate equivalent. So, V1 ml of EDTA, V1 ml of EDTA requires 20 ml of V1 ml of EDTA required for a 20 mg of calcium carbonate equivalent. So, 1 ml of EDTA is equal to 1 ml of EDTA is equal to 20 by V1 mg of calcium carbonate equivalent. So, 1 ml of standard hot water which is equal to 20 ml of calcium carbonate equivalent. So, this is the procedure used for the standardization. The next one is, the second part is estimation of total hardness. The second one is, the first one is standardization part. Here 1 ml of EDTA requires a 20 by V1 mg of a calcium carbonate equivalent. Let us see 20 ml of sample water requires V2 ml of EDTA. Therefore, 1000 ml of sample water requires V2 by V1 into 20 into 1000 by 20. So, for standardization of for estimation of total hardness, by it is a V2 by V1 into 1000. So, by using this formula, we can find out the total hardness. So, V2 by V1 into 1000 ppm. ppm refers parts per million. The unit used for representing the hardness is a ppm. And the third part is estimation of permanent hardness. In the estimation of permanent hardness, hot water will be gets boiled. So, boiled water is utilized. So, a 20 ml of boiled water, the 20 ml of boiled water contains V3 ml of EDTA. It contains V3 ml of EDTA. The same thing what we have discussed here, the same calculation will be followed. So, therefore, the 1000 ml of, instead of sample water, here we need to substitute. Therefore, 1000 ml of boiled hot water contains a V3 by V1. Therefore, 1000 ml of boiled hot water contains V3 by V1 into 20 into 1000 by 20. So, permanent hardness equal to permanent hardness, which is equal to V3 by V1 into 1000 ppm. Now we have determined the total hardness and we have determined the permanent hardness. The last one is a determination of temporary hardness. It is a simple thing. By comparing the total and permanent hardness. By comparing the total and permanent hardness, we can get the temporary hardness. Determination of temporary hardness. Temporary hardness equal to temporary hardness, which is equal to total hardness minus permanent hardness. Total hardness minus permanent hardness. So, this is the final one. See, we have standardized the hot water. That is the first iteration. In a second iteration, we are estimated the total hardness. It can be done by using a titrating the EDTA with a sample hot water, and the sample hot water is subjected to boiling. Now, during the boiling, the temporary hardness will be removed, and it contains only the permanent hardness, and the permanent hardness is estimated. Now, we know the amount of permanent hardness and amount of total hardness. By comparing the amount of total hardness and permanent hardness, we can get the temporary hardness. So, this is about the estimation of hardness by EDTA method. Thank you.